You know, there is always this question in Satisfactory. How one can make a factory that does not look like an orange box? When it comes to architecture in Satisfactory, brutalism is the first logical step. Art Deco works well. Neo-futurism? Well, it's a thing. But sometimes I just wake up feeling totally Piet Mondrian and make avant-garde inspired computer factory in Satisfactory. Yep, fancy-shmancy cube. And this factory makes 24 computers per minute. It is modular, with a single universal blueprint producing 3 computers per minute. Right now, it is stacked in 4-way symmetry 2 times vertically, for a total of 8 modules. And this is how we make 24 computers per minute. When it comes to copper and quartz conversion, this factory used the most efficient water-based recipes in the game. Thus, this factory used the least possible amount of raw resources. For example, it is 3.3 times more efficient in copper use and 25% more efficient with quartz. Also, as a side benefit, this factory does not apply oil products in a production chain. And the most important are several unusual exterior techniques used to construct this building. So today in this video, I would cover those exterior techniques, especially how I have made those super vibrant colors for concrete pillars. I will talk a bit about avant-garde inspired exterior design and its history. Then, I will dive deep into a schematic of this factory and why using water-based recipes for computer production makes a lot of sense. And finally, I would also talk about other blueprint factories in the similar tiers, like my updated heavy modular frame factory for Satisfactory 1.0. After all, this computer factory is a part of a bigger picture, with the whole city filled with blueprint factories. So without further ado, let's talk cubes, colors and 4th dimension. For a long time, I was really bound to painted beams to make anything with a vibrant color in Satisfactory, like those gradient facades in a number of my blueprint factories. And this is very inconvenient and one-sided. You cannot really just take any building piece and color it accordingly. It have limited the shape and visual variety of things one can do. So, for a long time I have been a fan of abstract art. The art that have a structure and geometric theme going on. And replicating that in a Satisfactory, well, it's not an easy feat. So, there was Piet Mondrian, probably the most famous painter and art theoretician out of a bunch of other historic figures at the time. And Piet Mondrian was a proponent of the style in Dutch, which is, well, literally the style in English, and he transformed that into his own art theory of neoplasticism. The most popular example of this is composition C, or number 3, with red, yellow and blue, from 1935. Another great example would be Theo van der Burg's composition 7, The Three Graces, from 1917. The abstract ideas of all this art was translated into architecture. For example, we have Rietveld Schoede House in Utrecht from 1924, the only building realized completely according to the principles of the style. And another architectural thing hitting close to the home would be this pavilion Le Corbusier built in the mid-20th century. And if you don't know, well, Le Corbusier is one of those very famous brutalist architects. And this is like where a lot of those brutalist architects initially drew their inspiration from, although they sort of lost all the color in the process. But we can do better in Satisfactory. And now we can finally color concrete into a proper vibrant colors. So, we can color concrete pillars, but when we go for just an ordinary color, well, it's quite dull. And here is a trick. When you choose the color in Satisfactory, you can crank up it beyond the certain thresholds. Just type the number above 1 in the 3rd row. Here I used 100. And it was a bit too light blue for my taste. So, I went for power of 25 with the same color, and we got exactly the shade of blue I want. As you can notice, I already have applied similar trick to the white concrete pillars. By the default, white concrete is still grey, but if we give it a power of 100 units, well, we finally can have the proper white concrete in Satisfactory. Yeah, unfortunately this technique does not apply to concrete walls, but we can use it on concrete foundations with the same effect as concrete pillars. For this factory blueprint, I decided on blank white facade. Well, the facade that I would color later. In this way, I can break up the repeating patterns even further. For the colors, I am using blue, red and yellow, something very similar to Piet Mondrian paintings. There's the whole geometric art theory behind that, but me personally, well, I just throw things onto the walls literally until it works. So yeah, there's that. The most fun part about those art theories actually is the fourth dimension stuff. You see, anything in the universe is in a constant motion, and with the passage of time it will change. For example, a painting will start to lose its color with passage of time. Or even something simple like the change of light during the day will result in different visual outcome at different time of day. So in a sense, all the art of architecture is in a constant motion. It is truly four-dimensional in nature. You know, just like all those box apartment buildings that look nice the first 20 years. And then they just transform into true monstrosity when the fourth dimension hit them hard. Initially, this whole build was inspired by this brutalist building in Los Angeles. Although I cannot really use those foundation pieces to achieve the same results, and I am using 6x6 blueprint base to make this facade happen. And as it turned out, I was not really able to fill the 6x6 facade with a similar height of a window. So, this is why there is two different types of windows. First, I have made two separate window blueprints, and then I just stuck them together in a staggered shape. This allows for uneven facade design and works even better with all the artsy color shenanigans. And to make the facade more 3D in nature, well, in between concrete pillars, I am using painted beams colored with carbon black paint. On the edges there is exactly 2-meter gap to fit yet another concrete pillar, but this time around on its horizontal side. This blueprint is not exactly 6x6, so it do require a bit of fiddle with a nudge tool, and it can be placed as exact cube in 4-way symmetry. Yes, you just need to nudge it a bit into the place. Another feature of this build is the maintenance shaft. There are 4 resources coming in, including water, and there are computers coming out. All the resources are on a manifold, and this means when you are stacking several blueprints on top of each other, well, you are just connecting top and bottom outlets to each other with conveyor lifts. So in a sense, you can treat every single blueprint module as a separate machine with a set of inputs and outputs. Liquids and water do behave a bit differently. Unlike the belts, you can just bring the water on the roof on the one side of the building, and then just use the water pressure to feed all 3 other sides with water. This is the way how to save on the use of extra water pumps. Since I want the top blueprint to have a window instead of a doorway, I only manually create an entrance in my blueprint factory when I need to access the maintenance shaft from down below. This is how I make only one universal blueprint and not creating the top and bottom separate blueprints. Another question I do get about how I connect my blueprints is, well, the logistics floors. As requested by my Patreon member, here's a snippet of what happens down below. A bit of the spaghetti, but I make sure that I have enough headroom to fit all the belts without any criminal clipping. Usually 12 meters of height is more than enough to include extra transit belts. Just make sure not to go lower than 8 meters, because it becomes a bit of a pain as the factory grows. And with all the exterior covered, now let's talk about the main part of the puzzle. How this factory is super efficient and what alternative recipes are being used in this factory. When we are creating modular factory, we need to think about certain limiting factors. Usually, they are input resources and other desired output ratios. And my main limiting point in this factory was 300 water in Mark I pipe feeding this complete building. And this can sound as a very counterintuitive thing for a computer production. While in Satisfactory, water is often used as a last stand resource when it comes to converting like the whole map of the resources, well, in real-world computer or chip manufacturing is, well, very closely bound to the pure distilled water. So it's sort of a roleplay of a real thing once we start to use water in our computer production in Satisfactory. And the second part about water, well, is that we are also becoming super efficient with our computer production. Alright, silicon. Silicon is probably the most studied material on the planet Earth. While early electronics used germanium as its base, silicon is just a better material in almost every single regard. Very pure silicon is the basis for wafer fabrication, and wafers is the base for microchip manufacturing, that is a part of any circuit board inside of a computer. Silicon wafer undergoes many fabrication processes, such as doping, ion implantation, etching, thin film deposition of various materials, and photolithographic patterning. Finally, the individual microcircuits are separated by wafer dicing and packaged as integrated circuit. Considering all the steps described above, silicon is very special material able to withstand multitude of processes, and at the same time, it is remaining cost-effective. First, silicon is formed with so-called Czochralski method into ingots, and then those ingots are sliced into the thin discs of wafers. Wafers are cleaned with weak acids to remove unwanted particles. There are several standard cleaning procedures to make sure that the surface of silicon wafer contains no contamination, and almost every step of microchip formation involves some sort of post-processing and cleaning with either distilled water or acids. Safe to say that without plentiful source of pure drinking water, modern manufacturing of microchips is almost impossible. In my computer factory in Satisfactory, I am using a total of 3 water-based recipes and refineries, well, as the basis for crystal computer recipe. There are pure quartz crystals, pure copper ingots, and steamed copper sheets. And with exactly 3 computers per minute, I do hit the water consumption of 37.5 units per minute. Multiply it by 8 for 24 computers per minute, and you get exactly 300 water per minute. Also worth mentioning is the use of silicon boards with the crystal computer synergy. That alone allows to avoid any oil in the production chain. The inputs of copper and quartz does not make a lot of sense, but generally I just round off those numbers up to 15 copper and 45 quartz per minute, and this is 120 copper or 360 quartz per minute when stacked 8 times. Since I'm using 4-way symmetry with 4 maintenance shafts, you can push all the factory stuff up to 32 or even 64 stacks. I think like it's a bit of overkill in my book. I really love and enjoy this small 24 computers per minute building. This factory relies on my reinforced iron plate production for crystal oscillators. I already shared updated modular blueprint for reinforced iron plates previously, and today with my computer factory I want to share my updated heavy modular frame and concrete factories. It is a design iteration of my update 7 blueprints, but internals for heavy modular frames is, well, quite different. This time around I really heavily rely on concrete and molded pipe alternative recipe. Previously I was using double the amount of coal and way more copper to achieve the similar results with the heavy modular frame production. And one can ask, but why I am talking about this in a computer factory video? Well, it is a part of a bigger picture. Previously, I already shared space elevator skyscrapers for the phase 3, and one of those skyscrapers for adaptive control units, well, it required the input of 12 heavy modular frames and 24 computers per minute. So yeah, it sort of all comes together. Once again, reinforced iron plate, modular frame, rotor stator and motor blueprint pack is available for free on my Patreon, just sign up and download. Heavy modular frame and concrete factory pack is now also available on my Patreon for free. There also was the older version of my computer factory during update 8 that was available as part of my huge update 8 blueprint mega pack, and today's computer factory with 2 blueprint templates for Windows and TSMC logo, they are available for my paid Patreon members as early access blueprint pack. Once again, thank you for all the Patreon supporters. Your support is the only source of the revenue for this channel at the moment, and it truly counts. This week, I want to welcome new member with a pledge above $10 on my Patreon, so let's welcome Expat John. As always, thank you for watching, have a nice one, and Yakis is out to think about silicon. It is truly remarkable how one thing can be a mold for bakery, computer chip, a body shape enhancement implant, and a very bad fictional take on alien life at the same time.